or if we will not be able to prove that and just fail to reject the null hypothesis. So let's try to solve this problem using STATA. STATA is a software, a very famous statistical software that can do any of the tests that we have been using. So let's see how this works. And again, I'm not going to ask you to do that, but I just want to show you what kind of information do we need to run this test, and what is the output that we can see from this software. And this is really important. I want you to focus on the parameters that we need to run an independent t-test. So I'm going to open the software here. Okay, so I'm going to ask the software to run classic test of t-test calculator. And our sample here is 2 sample, right? Not one sample like last year when I have 2 sample. So it's going to ask me about some information. It's going to ask me about the sample size for each group, right? So we need sample size. This is very important. The other thing it's going to ask me is the mean for each sample, since we're comparing the mean. And then it's going to ask me about the standard deviation for the mean in each sample. So this is the third piece of information. And then the last piece of information that it needs is the type 1 error or the alpha error. So let's fill in this information. Don't worry about the unequal variances. So what is the sample size for, let me bring the PowerPoint slides again. So what is the sample size for group number 1? Okay, 1623. What about sample 2? 1911. How about the mean for sample 1? 128.2. And how about sample 2? 126.5. Okay, what is the standard deviation for the first mean?
17.5.
Okay, it's 17.5. That's good. And how about the second sample? 20.1. Okay, and let's say the alpha here is 0.01. So which one should I choose from these confidence intervals? 99, correct? Because if the alpha is 1%, then the confidence interval will be the complement 1 minus, it would be 99. And then I'm going to run this test, and here's the output that I get. Okay, I'm going to show you the same output here on the slides. Okay, so this is the output you get from the software. So a lot of information, but if you look at it carefully, you'll find that it's very simple, and it's basically most of it is what you have given the software. Then they provide you with some information that help you make the decision. So the first piece of information here is the observation itself. X is probably the group of men, because it's observation. Is it the group of men actually or women? Women or men? The first one. Men. Okay, so 1623, and that was the mean in the men because he has the higher one. And then the second group is a group of women, 1911, and their mean is 126.5. That is the standard deviation that you have entered into the software. And then this is the difference, the numerical difference between the 128.2 and the 126.5. It's 1.7. So this is the numerical difference, but we don't care much about this. We want to know if it's statistically actually different or not. So it gives you a confidence interval for this mean difference of 1.7, which is about 0.07 to 3.33. Does this confidence interval, that's a 99% confidence interval if you notice, does this confidence interval tell you that there is a statistically significant difference between the two means? Yes. Why is that? Because it does not contain 0. If we're looking at the difference, we do not want the confidence interval to contain 0. So what happens if it contains 0? What does it mean? Why wouldn't you reject a null hypothesis if it did contain 0?
Because it shows no difference by chance.
It's a possibility. Thank you. It's a possibility It's a possibility, even if it's one time. It is a possibility that one time the difference would be 0. If that's possible, even one time, then we cannot accept that possibility. So that's why if it contains 0, we would fail to reject null hypothesis. Another verification of the statistical significance is a p-value, but the software provides you with 3 p-values. It provides you with a p-value if you're looking at the left-tailed question. It provides you with a right-tailed if you're looking for something greater than or higher than, and it provides you with the absolute difference, which is just a difference, if you're looking for just a difference. In this case, which p-value are you looking at? What was the question? That the mean systolic blood pressure in men is what? Higher than. So which tail is that? Right tail. If it's right tail, then you're going to be looking at the greater than, and that's 0.0036. Is that p-value significant or not? It is statistically significant. Why? It's less than 1, less than alpha. And what's the alpha here? It's not 0.05, it's 0.01. So that's why I guarantee you there will be a question in the exam that's tricky like that. So it's not 0.05, although in both cases it's significant, but that's not the right reason. It's significant because it's less than the alpha, that's correct, but the alpha here is 0.01. So pay attention to what the alpha is. That's basically the main thing that we're going to be doing today in the applications. But there are some concepts, key concepts that we need to go over, but that is how you compare two independent means using the software. Okay, so again, there is a statistically significant difference between the systolic blood pressure in men and women, and we can conclude that men have higher systolic blood pressure than women. That's how we put it in lay language. And the p-value is less than 0.01. And what does 99% confidence interval mean? It means that we are 99% confident that this difference, the 1.7 millimeter mercury, is between 0.07 millimeter mercury and 3.33, and it does not contain 0, and that's why it is statistically significant. In today's applications, when I ask you to indicate the units for the difference, if possible, it's like in this case, if you know the units for blood pressure, I want you to use it like 1.7 millimeter mercury. Don't just use numbers, say the difference is 1.7, if there is actually like a unit. Okay, so notice that in the previous example, we arbitrarily designated men as group 1, right? We chose the first group to be the men and the second group to be the women, right? I'm not sure if you recall from last time, sometimes when you were trying to calculate the difference between the proportions, you would get the correct statistic value or confidence interval, but with a negative sign or opposite sign, right? Do you remember that? Some of you? Okay. And I told you that it just depends on how you arrange them, which one do you put first. And it just reverses the way you frame your question. It doesn't mean it's wrong. It just frames your question differently. So initially, if we put it this way, we were asking if men, we put men first, so if the systolic blood pressure in men is higher than women. And it makes sense because they are numerically higher. Imagine if we entered the same exact data in the software, but we entered the women first, the 126 first, and then the 128. We're just reversing the question. There's nothing wrong with that. We're asking now, what are we asking now if we put the women first? If the systolic blood pressure in women is less than in men. So what would you expect? You should expect that this difference would be the same but negative, because now we're asking if it's less. And you should expect that the confidence interval would be flipped. It would be flipped with a negative sign too. Both of them will receive a negative sign, and it would be flipped. And the probability shouldn't change, but you shouldn't be looking this time at the probability greater than. You would be looking at the probability less than. And you will see that this probability actually goes on the other side now. So if we look at the output, this is a new output. If we put the women first, you will see that everything is the same. It's 1.7, but with a negative sign. The confidence interval has been flipped, with both having negative sign, which is still statistically significant because it does not have 0 in the range. And then also the t-value gets a negative sign, and then the probability now, we're looking at the probability less than, it's still the same p-value, but in the left tail. So this is just a side note. There's not going to be anything about that tricky in the exam, but this is for you to understand how things work, and I want you to know how to interpret it in whatever way it's presented to you. So, as you could see in the example, the following are the parameters that we need to calculate, again, the difference between two independent means. What's number one? Can anyone tell me what are the parameters that we needed to calculate the difference between two independent means again? Sample size for each sample. What else? The mean. We needed the mean for each sample. What else? The standard deviation for each sample. And what else? The alpha level or type 1 error, right? These are, this is the information that we needed to calculate the difference between two independent sample means. Okay, let's shift the gears a little bit and talk now about the paired approach or paired samples. And again, when I mention paired or matched sample, I'm talking about one sample that is being assessed before and after an intervention, but not only that, it can be actually something else. There's also another approach to having a paired design, other than one group being tested before and after. Can someone try to imagine like a different design for still having kind of a paired study design, other than pre and post or before and after an intervention? We actually discussed this in clinical trials. There was a design called the crossover design, if you remember that. Do you remember the crossover clinical trial, randomized clinical trial? We talked about two designs, the parallel, actually more than two, but let's focus on the parallel design and the crossover design. Can someone tell me the difference between the parallel design and crossover design in clinical trials?
Parallel, you're looking at two things. I think I know it. Yeah.
Wasn't the crossover the one where both groups were going to receive
after a certain
treatment and then the switch?
Yeah.
Exactly. Thank you. So both groups
Contamination.
crossover. If you remember the energy shot, the caffeinated energy shot drink, each group would receive the intervention or the placebo at one point. So one group would receive, each group would receive the two treatment. They would receive the placebo, and then the next time they would receive the caffeinated energy shot. And that's good because each group served as their own control, right? If you have two treatments and you receive the two on the same sample, on the same group, now we can tell for sure if actually the effect that you have seen is from the treatment and not from something else. And that's an advantage of this design compared to if you're having two groups and you're testing the placebo in one group and the intervention or treatment in one group. Because sometimes there are different characteristics, other characteristics that are different between the two groups that might actually interfere with the experiment. And sometimes we know these factors and sometimes we do not. And if you remember, we call this confounding. Confounding bias means that there are other factors that intervene interfere between the relationship of the intervention you're having and the outcome that you're seeing. So you cannot say 100% that the effect that you have seen is from the treatment or from the intervention. So a good thing again about the paired design is that one group receives two interventions. We give them this first intervention, let's say for 5 days, and we see the outcome, and then we give them the second intervention for another 5 days, and we see the outcome in the same group. So that's actually a better design. The parallel design is actually the two independent groups. It's like control and treatment. And that's it for treatment A and treatment B in two different groups. That is the parallel design. And I want you to refresh your memory again about these two definitions and we'll cover them now because they are just related to what we're covering today. So again, the parallel design is more like an independent two samples. So treatment A, treatment B in two completely different groups. Crossover design is one group receives the two interventions. So they receive the first intervention, then they receive the second intervention. So again, we have so far assumed that we are testing the difference between means from samples that are independent. That's what we have been doing so far. An alternative study design is to compare what we call paired samples, or we call them also dependent samples, or matched. And I want you to know all these things. So paired or dependent or matched. The other one is unpaired or unmatched or independent. So the goal of these studies might be to compare the mean score measured again before and after an intervention. So we give a treatment, for example, again for weight loss, and we measure the weight before and after, and sometimes even people call it pre-post test, or to compare the mean scores obtained with two conditions or two interventions applied to the same participants. So the same participants go under two interventions one at a time. And that is like the crossover, again, the crossover trial design. So an example of comparing means before and after an intervention in one study group is the reduction in systolic blood pressure in a group of women using a treatment A compared to baseline. There's no other treatment. We just measure the blood pressure at baseline before they receive any treatment, and then we give them treatment A and measure, let's say, after 6 months how their blood pressure is. That's a pre and post in the same group. And our hypothesis, or our null hypothesis in this case, is that there is not going to be any difference. The treatment is not going to work. Their blood pressure before and after treatment A is going to be the same. However, the alternative hypothesis would be that we will see a difference that treatment A works, that their blood pressure improves after treatment A compared to the baseline. Any questions so far? The other example for a paired experiment is, we said we compare means with two conditions for interventions in the same study participants. An example is we take one group, just one group, and we give them treatment A, and we try, or see if it works, and then give them treatment B, not at the same time. That's the crossover design. And then we give them treatment B, and we see the outcome from treatment A and from treatment B in the same group, not in two different groups. So in this case, our null hypothesis would be that the outcome or the mean blood pressure when they take treatment A is going to be the same as when they take treatment B, right? That's no difference. But the alternative hypothesis would be that the newer treatment B would result in lower blood pressure compared to treatment A, in the same group. So treatment B is better than treatment A in the same group. So again, what are the advantages of the paired design? So suppose we wish to compare the effectiveness of two different sunscreens, sunscreen A and sunscreen B. So there are at least two ways in which we can conduct this experiment. One method is to select just a simple random sample of subjects and give them sunscreen A, and then another independent simple random sample and give them sunscreen B. So what is that design so far? Is it paired or unpaired? Is it dependent or independent? Independent, two completely different groups. The word independent here means they are completely different groups. We're gonna give group 1 sunscreen A and group 2 sunscreen B and compare the difference. There's one problem with that approach. What is that problem? Or one possible bias. Well, there are many types of bias. Selection bias, you might select a group that's actually less sensitive to the sun anyway. So if they receive one of these two sunscreens, it might not be effective, but because they are less sensitive to the sun, they might not incur a lot of burning anyway, right? So there are all kinds of bias, again, because these two groups would be different in many characteristics, and some of them we know and some we do not. But that's one approach to do such an experiment. And we send again the subjects out into the sunshine for a specified length of time, and then we measure the damage from the rays of sun. So what we'll probably notice is that maybe, as you guys said, maybe the ones who receive sunscreen A might have darker complexions and be naturally less sensitive to the sunlight, so we expect that they will incur less damage from the sun. So in this case, is that because sunscreen A is really effective, or is it because they are naturally less sensitive to the sun? And that we do not know. And that's a disadvantage of the unpaired or independent design, and what we call a confounding bias, if you remember. So a better way to do this experiment, imagine if we took just one study sample, not two, just one, and we asked them to apply sunscreen A to half of their back to the left, for example, and sunscreen B to the right. And we just compare the difference in the damage from the sun rays in the same group in each study subject on both sides. Wouldn't that be better? That would eliminate a lot of this confounding bias. And that is the paired design and what we're suggesting to do. So again, after a specified length of time, we can assess if half of the back receiving sunscreen A tended to be less damaging, and we could more confidently, using this design, attribute any success or failure or effectiveness or treatment failure to the sunscreen, not to any other factor, because it's the same person putting the two sunscreens on his body. So to summarize, what are the two major advantages of the paired design? Each subject serves as their own control, as you can see. They serve as their own control. We don't put sunscreen A on one subject and sunscreen B on a different subject and compare them. Again, because they have different characteristics. They are not the same people. But if you apply both of them on the same person, you avoid that because each subject serves as their own control. And that is, again, remember that very well. This is what we do in which type of trials? Crossover. Okay, how about the other design? To put sunscreen A on one subject and sunscreen B on the other subject? That is parallel clinical trial design. So the second advantage of a paired design is to again eliminate the person-to-person variability or the confounding. That's what we are trying to remove, so we can focus only on the intervention. Does the intervention work or not? That's what we want to know. We don't want to be confused with other factors that might interfere with this experiment. Okay, so how do we, we're done with the theory and all of that, but how do we do, again, a comparison between two means, whether it's dependent or independent? It's a t-test. T-test is a test used to compare two means, whether it's two independent samples or a dependent sample. And again, I want you to remember these names. Unpaired is the same as unmatched, is the same as independent sample means. And for that, we use a t-test, just a t-test. We don't even say sometimes unpaired t-test. So if you're reading an article and they say we use t-test to compare the means, it automatically means that these are two independent samples. If they were paired samples or matched samples, they would have to say we used a paired t-test. But if they just use t-test, it means that it is unpaired or two independent samples. But just for the sake, since we're learning here, so t-test is the same as, sometimes they put a dash or a hyphen, sometimes they don't hyphenate it. It doesn't matter. I'm just trying to kind of be accurate and complete here. Sometimes they would use unpaired t-test or unmatched or independent t-test. These are all synonyms for the same thing. The second approach, again, is a paired or matched or dependent sample means. We're using either one sample and comparing intervention, the outcome from an intervention before and after the intervention, or if we are applying two interventions to the same sample, like the crossover design. And in this case, if you're reading an article, they would have to say a paired t-test has been used. You would not say just a t-test, a paired t-test. Sometimes, or some people call it pre-post t-test, if this is the situation, or matched t-test, or dependent t-test. Again, I want you to know all these synonyms. Okay, so one very important thing. Last time, if you recall again, we covered comparing two or more proportions. That was the title of our class. Comparing two or more proportions. Today, I intentionally focused on comparing only two sample means, because if you want to compare more than two sample means, that's a completely different story and a completely different test. And we'll cover this in upcoming classes. So t-test is only used to compare two sample means, not more than two. Remember that very well. The test that's being used to compare three or more is called ANOVA, or analysis of variance. But you know that we will cover later. We're not going to talk about it at all today. So again, remember t-test is used to compare two sample means only, and ANOVA is for three or more. So how do you, once you reach, we already covered that in the example in the beginning of the class, how do you make a decision once you run a statistical t-test, whether it's paired or unpaired? Again, the three different approaches that we always use. You get a t-value, you saw it in the report that I showed you, and then you compare it to a critical t-value. But we're not going to do that today actually, because that's just not common. People use it with the z-test, but it's not very common to be used with the t-test, although it's completely valid. So if you have the t statistic or the t-value, you can compare it again to the t critical value and see if it falls in the rejection region or not, and all that stuff. But we're not going to use it today. Today we're going to focus on two approaches, using the confidence interval and the p-value. And as you all know, it seems like you now you've mastered it. If the confidence interval for the difference between the means does not contain zero, then it means the results are statistically significant. So again, if the confidence interval contains zero, if it contains zero, then we fail to reject the null hypothesis. If it does not contain zero, then we say that it is statistically significant. And it doesn't matter if it's paired or unpaired, in all cases, that's the rule you use. And then the b-value, for the b-value, we reject the null hypothesis if the b-value is less than the alpha, whatever the alpha is. If the alpha is 0.5, then let it be. If it's 0.01, if it's anything, we just care that the b-value is less than the alpha in order to reject the null hypothesis. Remember, I don't want anyone in the exam to be wondering if I did not provide the alpha level, or say, oh, the alpha level was not provided, and complain about it. If it's not provided, it is 0.05 by default. If it is something else, I'm going to tell you let alpha be, or let the significance level, or let type 1 error be, using any of these languages. Okay. That said, and now the applications, before you start moving, I have already uploaded the application. It seems like some of you are opening it already. There's another content page on Canvas. If you open it, I'll show you. I'm not going to distribute the applications today. I'm just going to give you white papers to answer it, but there are a few things that I want to tell you before we start. So if you look at today's date, it's this one, comparing two sample means applications. And we just click on that to download the PDF file, and it has 10 applications. These applications are a mix of two things. Some of them are about two independent sample means. Some of them are about comparing two independent means, and some of them are about a paired study design when you will run a paired t-test. I will let you figure this out, and that's one of the questions actually you will have to answer. For each application, I have provided you with the output already. So I ran the analysis on Stata, and I provided you with the output, so you don't have to do anything. You have the output that is the same that we did in the first example. But I want you to focus on answering the questions accurately. For each application, question number A would ask, are the data taken, and I'm going to just provide a simple answer, like what I expect from you. Are the data taken from independent or paired samples? This is very important to know actually how to answer the question. I want you to just tell me independent samples or paired samples. depending on the background information that you're going to read. What is the mean difference? The mean difference is just a numerical difference between the two means that you are comparing. So if it's not, it's already provided in the output, but even if it wasn't, you should just subtract them. So this is just the numerical mean difference. And standard deviation, you can actually cross ins. There's no standard deviation, right? Just the mean difference. Okay, so let me open the one I have because I hold this outdated. So okay, so what's the mean difference between the two samples? And if there are units, or if you can express it in units like millimeter mercury, or if it's weight in kilograms or pounds, I want you to express it in units. And then number C, what is the 95% for the mean difference? I just want you to look at the output and be able to find the confidence interval range and report it. Yes, write it again, report it to me. If you find it easier, you can circle it and just point to it and say 95% confidence interval or the 99% confidence interval. If that makes it easier. As long as I know that you know what you're doing, that's fine with me. But just write if it's a 95% or 99% confidence interval. And then the other part of the number C, does it show that the mean difference is significant or not? I want you to be able to tell if it is significant or not and why. You tell me because it contains 0 or because it does not contain 0. It might look very intuitive to some, but some are still learning. And then number D, report the p-value. Again, you can circle which p-value you choose, so you don't have to write it again. You can just tell me, well, this is a p-value I'm going to choose, or this or that, depending on the direction of the test. So circle it and tell me this is a p-value you choose. And then based on this p-value, I want you to tell me why it is significant or not significant. You have to tell me it's less than 0.01 or 0.05 or whatever. Just write it this way. One thing I wanted to bring your attention to, sometimes the software will report a p-value that looks like that, 0.0000. And I gave you a hint in the instructions. This just means that the p-value is really, really too small. That the software just cannot show it, which is a good thing actually. It means it's less than anything. So it will have to be significant. But how do you report it? No one would report p-value equal 0.0000. You just write p-value less than 0.0001. So that's how you report it actually. You don't report it like a software like this. Okay, so these are the things that I wanted to tell you. Here's a white paper. I'm gonna circulate some white paper. Again, this is individual. I want each of you to turn in their paper at the end of the class. You can still work together, ask each other questions, ask me questions, but I still want each one to turn their own individual work with their name at the top and group number or team number. Again, if I do not receive one from you by the end of the class, then I will assume you will not hear. So I'm going to circulate some papers, and if you have any questions, let me know. And once you're done, one thing, feel free to go to the bathroom or take a break if you like. I'm not going to give an official break. And once you're done, you can leave for the day. But you have to turn it in, remember that. Oh, and I think your boxes have staplers, right? So you can staple them together because you're going to probably need more than one paper. So staple them together before you turn it in, okay? Again, once you're done, turn in your paper and you're free to leave.
You got a what? You got a what? What's the song related? No, but it's supposed to be the same.
It feels like it's been threatening the right and right.
Like 2 weeks ago.
Thank you.
Thank you.
Enough for two people.
That's enough to put the whole right in the middle. Like, take it
Oh,
in the middle.
Any more?
Yeah. Need like one. Let's put the rest right there. Ow. Got my flu shot today.
Did you?
Yeah.
I gave 3 shots today.
You did? I gave one today.
You sound so happy.
Because I didn't make them believe they said I didn't feel it.
What?
Yay!
The person I give it to, they tensed up. And so like I was going in real slow, and then because they tensed up, I was like, and they were like, ow. And I was like, well, you shouldn't have tensed up.
Beautiful.
And she like, and then she looked at, and you was really nice. You were like, it's okay, my daughter, she's gonna try to get into your program, you know, if we all do. But she was like, no, you don't have that. That has to be, and so she was trying to figure out the package and everything, so to find out what so she opened another box and moved it and got a different with a different not light on it. So she took that whole box off this place. I was just scared. I was just like, what did I do?
Yeah, I wouldn't have known. I feel bad when they tense up though, because I'm like, you're just making it worse on yourself. Relax.
Don't go too far because you're giving some kind of breathing.
Oh, bursitis? That's the when you hit the nerve.
It will go down some because if you get it in this joint, it's going to start getting because immunizations are going into the joint. Something.
It was really hard to do that.
But they stop doing that. I know you don't.
No, just stand there.
I just go 2-3 fingers down and then right in it.
No, I clean the whole arm. I'm not getting a shot down here, but I'm working my nerves out when I go like this, okay? I can go whole arm clean. I know exactly what I'm going to do. Yeah, just, girl, the printer is throwing up. Girl,
Yeah.
the baby is throwing up.
I think I got loaded the wrong one.
I don't know what flu shot they gave me, but I never get a headache off of it. But today I have a headache. Yeah.
For some reason, I'm pre-filled this year.
Yeah, this was one of the pre-filled vaccines.
We never get pre-filled for
And it-
regular flu shot. And I was
It was nice though to use that because all you do is pop a needle in there and that's it. And it had the safety cap. You just throw it away. The needle was super tiny. I'll build my own insurance and everything. My shot. I'll put my own info in.
It's got to be dependent.
It's impaired, right? Where they're their own.
No.
They are their own.
The other one, that's
I'm
independent.
trying to get
That's impaired.
impaired. Okay, because the women are the.
Does anyone need paper?
Paired samples are dependent samples.
Huh?
Paired samples are dependent samples.
Yes. I think this is paired.
So one is paired. Who are they paired with?
Well, they have a pre and a post.
But do they serve as their own pre and post? Is what I'm trying to say. Okay, let me see. See, we have who she studied, but they weren't compared to somebody else altogether. They were compared back to themselves.
That's confusing.
Pre and post were given. Okay. This was pre therapy. Why do you have this up? Oh, I'm doing
Well, each person is both a pre and a post group.
So those are our cross-sectional, and he said cross-sectional went with.
So crossover study?
I was asking in the questions what is a 95% confidence interval?
Yeah, it gives 99.
Just realizing that sometimes it will be 99% confidence interval, so don't worry about the 95%. Sometimes it might be 95% or 99%. Just report it either way.
Okay, so paired means shoot. Cross-sectional and paired go together, which means
I wish you would post those slides.
gets there. So is it correct to say that with the cross-section, it's a paired design and each group is its own control? Is that how you worded it?
Each has its own control.
Each group
Yeah.
is its own control.
Because each person is part of both groups. They're a pre and a
so you get
post.
the crossover.
By dependent, does it mean depended on, it depends on the treatment that they gave, the outcome?
Or the data taken.
Or just the fact of pre and post being dependent?
I think it's paired because it's not an independent group. What do you think?
I think it's paired. Because we're testing the same group twice. You have your pre and your post.
Because the independent ones, they
Yeah,
wouldn't
each-
correlate with one another at all. It'd be two separate studies that you're comparing.
It says here in a paired sample t-test, each subject or entity is measured twice. So we did measure each person twice.
And a paired.
So this is dependent.
So this is
Do we have to,
a
like,
paired sample.
I just wrote dependent.
I just wrote a paired, but that's what.
What is?
That's
Negative 1.6.
okay. There are no units.
There's no units because it's on a score.
Negative 1 point right here.
Geriatric depression
What
scale.
does it mean? It's a mu.
Yeah.
Well, it depends. There's means of populations and means of samples.
What is this?
What is the 99%?
Is it the negative 3.1 in this case or not?
Expressed in units when
Is
shown.
it if it contains zero, you fail to reject it.
Yeah, if it contains zero, then it's a signal.
What do you mean by expressed in units? If known, if they gave us units.
So is that or not?
Negative 3.12. Negative 0.0.
Oh, that's the whole dog. That's what interval means. Remember I just said what number is it?
Where did you get that from?
What is it?
Oh, I see that right there. Yeah.
will fail to reject, and this shows that the results are not significant because it contains zero.
You got a negative and a negative.
It does not, and I put does not. So now that means the result are statistically significant, and we just leave it at that.
So it is this it is significant.
Yeah. You reject the
So
null.
it says what is the 99% confidence interval? But this says a 99.
Yeah, he said he.
Okay.
So we're rejecting, and it's not significant.
Yeah. How do we reach the conclusion? Does not contain zero?
We said, I'm so sorry. Y'all did say it was significant, right?
It's not
Not
significant.
not
But
significant.
it doesn't. They should be significant because it doesn't.
Oh no.
contain zero.
Significantly different is what we're saying. It is significantly different.
It should. Okay, so it is significant.
Yes.
Yeah.
That's what we're saying. Okay.
We're getting all tongue tied. I'm just gonna say significant difference.
I'm just going to say confidence interval does not contain zero. Is that sufficient enough explanation? How did we reach that conclusion?
Yes, it's all things.
Yeah.
Right, repetition. Okay, so what's the next one? Report the p-value.
I think it's a
left
It's
tail.
a left tail. It's talking about decline.
Just saying.
The question is, can we conclude based on the data
After treatment,
on average a decline in GDS?
yeah, they're trying to see if depression scores go down after
Yeah.
treatment, basically. Yeah, so it'll be a one-tailed left side.
So, and that's negative 1.64 or 605.
He gave us alpha equal to 0.01.
I don't think we know that one.
So P value, he says P value.
Oh, alpha is 0.01, so P is less than.
Left, so
Do we need to?
I give the p-value?
So are we having a calculator?
Is that the p-value? 0.0034?
Okay. Oh,
Wait.
okay, I got you.
Where in here did you say the p-value was?
Some have asked for the slides because it might help you as you work through this, so I just posted them. I'm gonna update them
what's
with
this one
the
then?
answers later, but for now, we
No,
really covered.
that's when it's two-tailed.
Oh,
Update them
okay.
later after class and also the answers.
What does it mean? I can write it. I just don't know what it means. Just write it first. How do we know this P equals this PR and these P's are P values? Because when we have two, it's always going to be P value. Is what you said?
Say that again?
How do we know down here if this PR is giving us our P value?
I don't know. He said the left one if it's a left tailed. He said the middle one if it's a two tailed.
The right
And he
one
said the
for
right
right
one if
tailed?
it's a right tailed.
Okay.
And
what he
because
said.
the p-value is less than 1,
I don't know how to give a better explanation.
then
Oh, that's what he.
Reject, so it is statistically significant.
Rejection alpha.
And we can include
So we're rejecting.
all of that stuff, right?
So we're rejecting the null, which shows again that the result is significant. Okay.
Yeah.
So patients who participate in this kind of therapy have a decline in all of that.
He said we were supposed to write this on white paper.
We're supposed to what?
Yeah.
He wants us to write it on the white paper. I've been writing it on my notebook.
Oh, okay.
That's because
Does he want us to state what it
the
means?
people who said if you want to just circle it, how else we gonna circle it? And he said if you just want to circle it and put CI or whatever, that's fine. But this is the one we got. But you know what? It would be good if I just transferred it over so I have my notes.
So this one is independent.
On two?
Right now.
Alright, yeah. Awesome, crazy names.
Yes.
The state we wish to determine if two samples differ.
So you have treatment group A and group B. Okay. So far. If the two samples differ, yes. This is independent sample. Let's see. Is that what you think?
They had a whole control group and then a whole nother group for testing. So what's that? That's a parallel? Yeah.
This is 9.63.
Yeah. What's the unit?
Oh yeah, there it is.
Oh, units?
They didn't give it to us. There's no units on the first one either.
Yeah.
So this one's going to be the other one, right? The independent samples.
They're independent because there's two different groups, a control group and a test group.
Yeah, so
So, okay, so this one, look at this, look at combined composite.
you know what?
What's your question?
So this one's going to be a 2-cell, right? We just want to know if there's a difference.
I think it might be the difference. Yeah, it's a difference. I wrote down the wrong one.
Oh, you were at the 10 and
The 10 to 14. Yeah.
that almost caught me.
Oh, on what?
There's like a combined confidence interval, and then there's a different one. I think you just write the difference one. The 6.5 and the 12.
Oh, okay, so it's the one on the very bottom.
Yeah, we gotta write the 6.57 and 12.68.
Okay.
Doesn't contain 0.
It's gonna be two-tailed, right? I mean,
Yes. Because they just want to know a difference.
if there
It's
is a
not
difference.
How is it different? So because it doesn't say more than or less than, it just wants to know if there's a difference, period. That'll be two-tailed.
Okay, so what letter is that? B?
Yeah. And that's the middle one, right? So just the 0, 0.
It's yeah,
P value is
probably
2.
so small.
Where did it give us alpha? Or do we just assume it's less than 0.05?
If it doesn't specify, then it's 0.05.
So what value we using this one? Less than
The middle,
middle one.
the point. Well, he said 0.001.
yeah, 0.001.
Wait, was it 2 or 3 zeros?
3.
3?
Is it 3?
It's not. It's in his note. Wait, so
Okay, so we reject the null, right? So there is a difference.
How many zeros is the price?
I have no idea.
3?
0.
less than 0.000.
Okay.
When it's
I'm guessing 3.
So we're rejecting it, so it's significant.
Yes. So that means there is a difference.
and it's the effects of the therapy that we're looking at, right? So there is a difference.
So this would be independent as well.
I haven't read it yet.
But it's a difference between the two groups.
Yeah.
Okay, between the two groups.
Yeah, I would say independent.
Because it's with or and without.
Yeah, with them. Yeah,
Yeah, it was with
you
or
have two
without.
different groups, one with, one without.
Because a with group can't be a without group, or if some miracle happened.
So that's anything.
Yeah.
So it would be non-significant because the confidence interval contains 0.
Got there, yeah.
Oh, it does contain 0.
Yeah, it does.
So, and it would be a two-tailed, non-directional.
Different levels.
Differing levels, yeah. They didn't give us the alpha, so it's 0.05.
Oh, this one has the unit for the mean, milliliters per unit.
Oh, yeah.
Don't forget.
Well, on B.
What?
On B, this one actually does have units over it, so it would be milliliters per unit.
IgG.
ml per unit.
Yeah. But the first two didn't have units on them.
Oh, right.
Almost messed up on the p-value.
Okay, that's correct. And then
So do we say just fail to reject the null?
Yeah.
you said
So there's no
There's no difference between the two means.
The one trick is the crossover design. There's a crossover design. One group receives 2 treatments. Those 2 treatments, one before and after,
How should I write something?
one group. There is no other group in all groups. One treatment. And units over here, I like that.
So this one's going to be a paired sample.
Doctor, give you treatment A. It's going to work for you. With that,
Yeah, because they're part of placebo and treatment. So it would be dependent. Or paired, same thing.
so to say the wrong or not.
It's the same subject. It was about 2 different
So is it millimeters for the units?
Okay, so we just did the placebo.
On number 4. For application number 4. Because it says on the analog scale it's 0 to 100 millimeters.
And then for different levels. So there was not.
So there was not.
So it'd be negative 9.618182 millimeters.
Thrombosis. And without.
Okay, there were. conditions with and without both. That's them. I won't
So is this a left tail?
text me.
It's kind of confusing.
Was lower days, yeah. For number 4, right?
Yeah.
Yeah, it's left tail.
You got
Uh-oh. Oh wait, never mind.
Yeah.
I was looking at,
0, 0.
yeah, 0, 0. I was like, wait,
I know,
wait,
I
wait.
did that same thing.
Yeah, they were crossed with themselves, so their hair, which is also called
I like how I just said uh-oh and you knew what I was talking about.
Yeah. I was just there.
the other text. If it's paired, it's also. What is it? They're crossing with themselves. So it's probably what? Crossover. Remember that. Remember? Whatever close to know how to test. Okay, anyways, back to so this is a period. Cross.
Every time I say that word, I'm saying that.
There is units. It's 0 to 100 mm.
Oh, right. Is that what we're talking about for the mean?
I don't know. I don't think that's.
Yeah.
Oh, 5, y'all say independent?
We ain't got that, brother.
Oh, you're still on 4? O and B, there's, yeah, you got the units. Mm-hmm. Yeah.
0 to 100 mm. I don't know if it's millimeters, but it's on an analog scale.
The paint scale?
It's analog, a visual analog scale. Paint intensity.
It's probably 8 millimeters.
Okay.
It's saying there's a difference between the two means.
Is there one tail?
Millimeters mercury.
Mm-hmm.
That's a really
Alpha.
bad chart.
Alpha.
One number 5. Like, they need to divide them. I see where he's kind of saying you could get confounding bias.
Alpha is 0.05. Alpha is 0.05. So p-value is less than alpha.
But if it's less than, it's rejecting it.
I'm assuming 5's independent.
So this means what did you say? So we are saying that the patient's pain level is lower already.
You said unpaired, right? Is that what you said?
I said independent, yeah, for number 5. And I remember him saying the disadvantage of having that type of study is confounding bias. So
Yeah.
he's randomly selecting groups, just like you go over there, you go over there. He might have put all the people that would have made the study better in one group
Yeah.
on accident.
That's it.
Doesn't contain 0.
So it's millimeters of mercury.
Yeah.
Okay, so I'm having a hard time on D for that application 5. Because it's asking what should the researcher conclude? They just wanted to make a positive influence. So does that mean they just want a right to test because they want a positive thing?
What?
Are we supposed to put units on the confidence intervals?
I haven't been. I don't know. Oh, it says they wanted to positively influence the results in the first sentence. So it's like they stated it in the beginning, I guess? Because they said,
Yeah, positively. So is that a right tail?
yeah. That's what I would say. Because that's what they wanted to look at, to see if the community pharmacy's capacity to positively influence the results of whatever therapy they had. Wait,
Let's see,
that
so
would mean
it's-
that they would go down.
And see, that's where my confusion's coming in.
Oh my gosh. Because a positive influence
So they want,
on blood pressure would be lowering it. But what if they...
so they're wanting blood pressure. to
Yeah,
go
they're wanting it to go
down.
down because they want to see if the positive results of antihypertensive drug therapy will show.
Rejecting?
Yeah. Can I just ask on this one? Because I'm afraid I'm
That's
overthinking
tricky.
it at this point.
Yeah, it made you think about what blood pressure is in antihypertensives. One-tailed.
Two-tailed. Two-tailed.
I think it's the left
That's what I'm
one-tailed.
asking all. Because
Is
if you
it-
read in the first sentence,
It says positively influence the results of antihypertensive drug therapy, though. I mean, and the positive result of that is to lower blood pressure.
so it's kind of confusing.
It's like a really tricky one. Let me state the. Well, I can't state the p-value yet. Get them hurrying over there. Oh, did you turn this thing?
Just need to go ask him.
Seems like 6 is
Paired.
paired, yeah. I want to say dependent, but I was trying to think of the other word. Are the units percent?
I think, yeah, units percent.
That's a percent.
Yeah, measured as a
percent,
percent.
Okay, so he said yes, two-tailed, because there's not a stated goal,
Yeah.
just because they want to positively influence something, that just means they want to know that there's a difference.
Oh, that's weird.
Yeah, he said that one was very confusing. So two-tailed.
Don't put it on the test.
So the p-value is 0.0011.
So that's still less than. Yeah, so that's still significant. So we reject them all, right?
In the middle.
Didn't state an alpha on number 5, did they? No.
What alpha did he give before? So he is less than alpha. So that means we are
Rejected. So the results are.
There is a significant.
there's a difference. So what else did I say? Because we know it's statistically significant. What else?
Do we have to state all that, like what it means? Because it doesn't say that in the problem.
The result, the antihypertensive drug influence the diastolic blood pressure. We're saying, yeah, intervention for antihypertensive
So on this one, it would be a right tail test where you want to increase the function, right?
On 6? Yeah.
diastolic blood
It's
pressure.
the same patient, so it's a catered to the
And the confidence interval does have zero. It's a right tailed on 6.
Right tail.
Increase function. Okay. So our p-value is 0.04 greater than
No, greater.
Greater.
It's the
Alpha
alpha's
is
0.001.
0.001.
Oh,
we can't say that the surgery was successful. Basically, the surgery doesn't reduce.
Oh my gosh,
they
I
said
read
that
too
the
big.
data was not sufficient to support the conclusion. Because it says they wish to know if the data provides sufficient evidence to conclude that. I just said it wasn't sufficient.
To prove what? That the
The
surgery.
surgery.
The surgery increased.
Okay. Thank you.
Is that the only one that's asked a question? On number 7? Oh.
The data was not sufficient enough to show the surgery increases due to EF. So just two, it's hold up, that's the one. Oh, it's hair.
Because it's the same one. So for 7, did y'all get 2 tails?
It's gonna be. Yeah, when I get down there, that's what I'm thinking.
Alright.
Was it yeah,
There's you
right here, 10 to the 6.
times 10 to the 6 per liter.
Okay. And it, P has the same root. P is unit is always right.
Yeah. 7, did y'all put independent? On 7, did you put independent?
For 7? No, I think it's dependent. Seven,
Is it
right?
dependent like 2 different groups? It looks like CD4 cells are part of both groups. Because they're part of like before and then follow up.
It's the same group though, right?
I thought, isn't independent when.
At baseline,
Am I confusing myself?
It's paired, right? Paired?
in therapy,
Paired is when they share groups, right?
patients who underwent 12 months
I think I'm confusing paired with
Paired is
parallel.
the same group, but they test them twice.
Yeah,
Is that what it
They
says?
test the same
that's what I
group
meant to
twice.
say. Just twisting myself up. Times 10 to the 6 per liter. So it's two-tailed on 7. It's a significant change only. Two-tailed.
So what is it?
For number 9, did y'all get left tip?
I've been
Just
done
started
it.
reading.
Yeah, it really says redeem. It's just like 6 hours.
Yeah, I think it's paired. They're using both.
8 was independent, right?
Okay, so they are the so A is paired.
Didn't have to put it in the
Yes,
together.
ma'am. It's gonna be a process.
Is there a unit on 8? Can't find one.
Rough that would be fine. The mean,
So for 10, is that independent?
one tail.
I don't see them testing it twice, but it's 2 separate groups.
You're way ahead of us.
Oh, I'm so
We're
sorry.
still on 9.
I am so sorry. I'll slow down.
I don't know where Bryce is at, but I'm still
I'm on
on
8.
9.
I had to go back to
Oh.
answer that. I didn't notice that they were asking questions right here.
Well, I'm on 10 now.
I went back and answered those.
Yeah, there's Is it later? See what I'm doing? So excited. Go ahead and study so that I can bring this weekend. Granted, I'll still
So if
study.
we reject it, what we saying?
We're
So,
saying
we are saying that
I agree.
there's sufficient
I mean,
evidence
Dr.
to
Latch is
indicate
I
that
really
the
feel like I need to go back
constitution
and
says the PA is not titled.
just to the school, let me get it with you. Okay,
see.
so,
Yeah, so let me know what he says.
we are saying that
Get me up on Facebook. Or heck, you want my
there
number? I'll give it
is,
to you.
so if you say sufficient evidence, we're saying that
I don't know. I've never seen it. Yeah, I'll be
the use of these applications together are areas where we have sufficient evidence to show that the use of alcohol, drugs, and use whether
I feel so much better this semester about this stuff than I did last semester. I don't know why I couldn't remember this stuff last semester because I got it.
so let's see, like this, okay, so it's saying
I
Yeah, thank you. Get that one for the CAL.
Oh, a 9? Did y'all put paired?
And top.
There, yeah.
Because the areas had both.
Oh, sorry, hold on. That therapy of,
No, the effect of UVB therapy and topical came together.
UVB.
No units again.
So,
Subjects in the study. So what was your question? Independent, unpaired.
POTRIO. Reduce this. That's
okay, so number 10. Yep, I'm sorry.
I know.
Pale. But they said independent. What did you say it was?
Independent, unpaired. Because you have
Unpaired? Okay.
you have guys that are multi-sport, and then you have specific rugby players.
Where are my two groups at? Who, X and Y. Okay. Y'all act like y'all the only ones in the classroom. So we ain't done.
Yeah, you tell them.
Hold on.
Fuck those guys.
Maybe this is my old train of thought. So we said it's multiple cause.
You have a group of 40 men,
Uh-huh.
and then you have another group of 24, a separate group
rugby.
that are only rugby.
40 men plus rugby. There we go. I see it now.
It takes me so long to write this stuff.
Y'all want to go over it before we leave, or
I don't care.
I'd like to just ask which ones y'all found units of measurement. I think there were only 2 of them.
Okay, so with B, we're going with what did we say before? One tail right side.
So there was only one failed to reject out of all of them?
I thought there was 2.
So what are we rejecting? We are rejecting the
Number
flag.
3, right?
Flag.
3 was fail to reject.
Have a B.
Are you talking about
And
the
6.
units?
On 6 we also rejected.
Oh, yeah. Okay.
Was 10 the last one? Okay, sweet.
You got a unit for 10?
I just
A
put BMI.
BMI?
I put BMI.
So, BMI. Uh-huh. In general, rugby players.
Huh.
That's the same thing I did, me too.
I'm confused about 10. Did any of the multi-sport people do rugby? You
I mean, in my
I don't.
know what I mean? Because they could have
They probably
been.
did because it's multi-sport. All 40 of those people.
Because that's a crossover right there, and that'd be.
you know what I'm trying to
That would automatically make it.
No, I think it's 24 other people.
Oh, no, I can't.
Yeah.
Yeah. Yeah, I'm gonna do it. Soon as she comes to this. She can take pictures the whole time. She can take pictures.
You know what I mean?
Yeah.
It's 24
I can
other
think of it
people.
both ways, and it kind of throws me off.
We said, you thinking that the difference between independent and fair is like when you doing your own.
Miss Lindsay, can you get those?
Yeah, there are two separate groups.
If you doing the same schedule as one person, the beginning and end, like before and after, it's gonna be fair. Like the competition,
Because it's that cross.
yeah, and then the contest, the who wins, and then the teachers. Because it's two different things.
You guys need to stapler it.
Yes, please. Thank
I'll
you.
probably do
Oh,
it.
you had rotation today?
I did.
Well, you look nice every day, but I don't like to tell people that they look nice on one day. It's pretty.
That was a good one, wasn't it?
But then they be hitting, baby. That was the color today, Alex.
Hmm.
Maybe
I just took the tie over in the truck.
I see y'all with y'all yellow.
Yeah, we woke up on the right side of the bed, but then she popped with that blue though.
She need the navy. Don't tell your navy was in for today. I don't know if y'all ever noticed that, but as a class, sometimes we all be wearing the same colors.
Never paid closely.
One day, like, with so many people in the room on, it was weird. Like, when we was in a group together,
Yeah.
it was crazy. You ready, Nico?
We
You gotta go to work
You
today.
good, Bryce?
Yeah.
Yeah, Thursday. Yeah, I'm off Thursday. We gonna go over.
Everybody? Oh, you can go if you want, girl. I was just asking if anybody wanted to. No one really said anything, so I
Wanted
put my
to.
stuff up.
What do you want to do?
Oh, just go over it. I mean, we don't have to. It's not a big deal. There were just a few more that I found a couple of units on.
So I don't have a coffee on here, but I need my coffee.
So for number 3, the milliliters per unit. For B, for 4, we put
And-
millimeters.
Yeah.
5
millimeters of mercury.
Yes. 6%. Okay. And then
7.
times 10
10
is
is
6 of a liter.
Yeah.
Okay.
That was the only other one.
And
BMI.
I put BMI for 10.
Awesome. I just wanted to double check.
So the
with
first
y'all, 'cause I
one
didn't see
with
them
units
till
was 4?
after I went back. Thank
Huh?
y'all.
First one with units was number 4? Oh, 3. 3.
Milliliters per unit.
Yeah.
I'm probably like a mile away.
Today?
Yeah, I got lucky. I went to park in the parking lot and that thing was completely full.
Oh, I didn't even
I
look
pulled
here.
into the, oh, see, that's where I finally found parking. I don't ever try to bother with this one, but I lucked out.
The way.
Really?
Yeah, just
Has anybody got an email about class tomorrow?
Yes.
We
No
don't
class?
No class.
They did it through campus, so they not have sent an individual email.
They need to stop that.
Yeah, I agree. You can download the app though, and it does alerts.
I have the app.
Oh, you do?
I do
It
that,
doesn't
but
give
I
me
just-
alerts on my app.
I didn't do the alert.
Yeah, it doesn't
Did
give
you
me.
did you set it up where you allow it to send you notifications
Uh-huh.
for like everything?
It's just not working. Just
I know they've
stupid.
been having a lot of issues with it. SGA's having a problem with their student organization.
All my push notifications on, and it's just not doing anything. Just
See you guys for the review.
Yeah.
See you Friday.
Oh yeah, I
Enjoy
saw
your
that
day
over
off.
here. Go finish. Go work. I'm just typing up.
I need to do that. I really need to do that. I'll do that tomorrow.
so.
Now these shoes, I'm not walking ankles. You know, they think they can walk over. Gianna Beanie can have them. If he has to walk in the shoes, do that, he can do it. No mind.
My husband got us a tour of the White House. I'm going to DC this weekend. I got a tour of the White House.
Oh, that's pretty sweet.
I'm freaking excited. Yeah, I'll be studying on the plane about every night, you know, as I'm passed out in the bed. But it'll be fun. I'm glad we got the day off tomorrow. I'm gonna start studying early.
You see Trump?
Yeah, I got you. Everybody
What?
did. I've never been before. My husband's been, but I haven't. And he hasn't been since 8th grade, so it'll be a lot of fun. I'm excited. Yes.
Dude, that's like you can see all of the Washington House.
I'm gonna see if we can. We've got the White House tour on Saturday, with the Capitol tour Saturday evening, and then Sunday is completely free. So there's oh yeah.
It's like it doesn't sound like you were it's kind of like
Reposting some pictures. You got everything first?
Oh yeah. I just went back to answer those questions for the first three.
Oh my
Because I just said significant difference for Jeopardy. I didn't
I got you.
elaborate.
Just elaborate. Okay, dude. Well, I'll see you on Friday, okay?
Okay, see you.
Not done yet.
So,
Round two. Round two.
But
the subject was for the same reason. Person outside. So I thought that's this girl is more
I'm starting to get a little sore, but it's normal. Yeah. Take it inside. Yeah, I get my first shot today. Yeah. Yeah. It took me forever. It took me forever to just get one finally.
Are you about to leave?
I was literally like,
That's it.
Done.
It's so easy.
and
You
they're
just
like,
gotta
"Ah."
make sure, like, for me,
Well, actually,
I did an old
did
lady
this.
first.
Finished
Oh, you did?
really quickly, and then they're like, "Ah."
Preceptor told you, like,
No, it was
80
because
days.
they were tensing up, so I fucked with them.
Is that mine? Oh, man.
It's because it was one of the techs, and they were nervous about flu shots for some reason. They don't like, get shots, so they tensed up. I told them to relax. They didn't relax. I was like, 3, 2, 1, relax. And then I did it, and then I could feel the tension, so I pushed through it. Because if I would have sat there and done it slowly, it would have hurt them more. At least that's what my mom told me. People get slow shots, it's the worst.
So it's for me, like,
So I was like, you know what?
I did a couple, and it was like pretty easy. And then when I got to Brookshire's and Emory, like the 4th week I was there, so I hadn't done a shot in like a month and a half, 2 months. They give me this